Alex, what is the first thing that I need to do?
I mean, honestly, I'd like to move 32 to the right, but I feel like that's wrong.
That is actually not what we want to do this time. Because what? What aren't all the same?
Numbers.
How about the letters?
Yeah, that's the very.
And I noticed that I have one singular y, but then I have an x squared and an x, which means that I'm not double completing the square. I'm only completing the square with what? The x's, because I have two of them, but only one y. So what I want to do is I want to get everything that's not an x onto the left-hand side and everything that is an x onto the right-hand side. So we're going to leave this 32. I'm going to subtract this 2x squared, and I'm going to add this 1. So when I do that, I get y plus 32 plus 1 equals negative 2x squared minus 16x. I can go ahead and simplify this by putting the 32 and the 1 together. And when I do, I get y plus 33 equals negative 2x squared minus 16x. Alex, what am I going to do next?
No idea.
Well, I know I want to eventually complete the square with the x's, correct?
Yeah.
Awesome. Can I do that if there's a number in front of my x squared?
No.
No. So what do I need to do with that negative 2?
But you gotta like put it like a C1. Like you gotta put parentheses around brackets.
I will when I start completing the square, but I can't do that quite yet until I get rid of that negative 2.
You gotta divide it.
Or factor it out of both of my x terms, correct?
Sure.
Yeah, let's factor it out because I still want it to sit out front because that's going to become my a value, but I don't want it currently attached to my x squared. So when what'd you say, hon?
Oh, it weren't factors.
No, I said we are factoring it out because I do want an a value here. I'm not factoring like a normal quadratic. I'm just factoring out that common negative 2 value. So when I pull out that negative 2, I'm left with the positive x squared plus 8x plus my C1. And I'm going to be adding that C1 to both sides, but when I add it to the left side, it's going to have a negative 2 attached to it. Why is it going to have a negative 2 attached to it? Because I have a negative 2 in front of the parentheses that has the C1 on the right. So that value has to stay attached to whatever my constant is. Now the really, really fun question. How do I find C1? 8 divided by 2 squared. So I go to the value in front of C1. That's an 8. I take that 8 and I cut it in half. And then I square my answer. So what is 8 divided by 2 squared? 16. 8 divided by 2 is 4. 4 squared is 16. I'm going to go ahead and put that C1 value in. When I do, I get negative 2 times 16 plus y plus 33 equals negative 2 times x squared plus 8x plus 16. I'm going to pause here to give you guys a chance to catch back up. And then we will continue on. That's fine. Brandon, what does it look like we're going to do next?
I'm guessing do negative 2 times 16.
Okay, what is negative 2 times 16?
Negative 32.
And what am I going to do with that negative 32?
Add it to 33.
Awesome. What's negative 32 plus 33? Negative 32 plus 33. 1. So that left-hand side becomes y plus 1. Good job. Any questions on that side? No. What do I do on the right? What was the whole point of completing the square over there? What do I know is going to happen with this quadratic? Factor into the same thing twice. So it's going to be a factor squared. So what number times itself equals 16, but added to itself equals 8? 4. So this is going to be negative 2 times x plus 4 squared. What is my last step here? Move the 1 back over. Good. So my equation is negative 2 times the quantity x plus 4 squared minus 1. That is a y equals parabola. So is it going to be a vertical, which means it opens up or down? Or is it going to be a horizontal that opens left or right? It will be a vertical, so it's going to open either up or down because it's y equals. So if you looked in the notes, we have this cool big chart. Anytime it's y equals, it's going to be a vertical parabola. Anytime it's x equals, it will be a horizontal. So you need to look at the notes for that. For this particular example, I would like to find 5 pieces of information, and then I would like to graph it. The first piece of information I would like to find is the vertex. The second piece is my axis of symmetry. I would like to find the direction of opening. And then I would like to find the focus and the directrix. And then we're going to graph it. We will not graph any more beyond this one, just because once you've done it once or twice, you're kind of done. Okay, what's going to be the easiest thing to pull out or find from this list of 5 things? Vertex, awesome. Alex, what's it going to be? You are so close. Negative 4, 1. Nope, just kidding. It is negative 4, negative 1. We're so used to it being opposite. So it is negative 4 because I have a positive 4 attached to my x, which means I need the opposite sign. And then it is negative 1 because it is the last value in my equation. So negative 4, negative 1 is correct. Good job, Alex. How about my axis of symmetry, Keaton?
That's my notebook.
Awesome. How about the axis of symmetry, Keaton?
It's gonna be positive x equals 2.
Is it positive 4 or negative 4? Negative 4. It should always be whatever the x coordinate is in your center. And it is x equals because it is a vertical parabola. So my axis of symmetry is a vertical line. Yeah, they are, right? That's why we do them first. Another fairly easy one is the direction of opening. Which value in my equation determines which direction my parabola opens? The a value. Where's the a value located? In front of the parentheses. A positive a value on a vertical parabola indicates that it opens up like a cup. A negative a value on a vertical parabola indicates that it opens down like a frown. Which one do we have here?
Down.
How do you know it's down?
You just say negative.
Negative is down. What is the negative number up there that told you that? Negative 2. Negative 2 is less than 0, so this will open down. I feel like you're on a roll and we shouldn't stop you. So now let's go ahead and find my focus and my directrix. Again, these come directly from that table that you wrote down in your notes. We're going to go to the middle column because that's the column for my vertical parabolas. What are the coordinates for the focus of a vertical parabola? Are we changing the x value or are we changing the y value? The y. So my x value is going to stay the same. And I'm going to take my y value and add to it 1 over 4 times my a value of negative 2. And then, of course, we're going to simplify that. So the -4, again, still stays the same. 4 times -2 is -8. 1 over -8, when I add it to -1, equals -9/8, which is the same as -1 and 1/8. So my focus should be -9/8. You can also turn that into a decimal if you so choose. Questions on the focus? How about the directrix? What do I do, or how do I find the directrix for a vertical parabola? Perfect. Y equals, my k value here is -1 minus 1/4 times my a value of -2. We already know that 1/4 times -2 is -8. So this is -1 minus a -1/8. That is the same as -1 plus 1/8, which makes it -7/8. Again, you're welcome to go ahead and do the decimal for this. So now these are our 5 pieces of information. Are there any major questions on those 5 pieces? Our last step here is that we're going to go ahead and graph this parabola. As I mentioned yesterday, you do not need to find actual points that exist on my parabola. I'm more interested in you putting these 5 pieces down and then approximating what your graph would look like from that. So I'm going to give you a second to finish writing these, and then we're going to go ahead and put the graph down. Some of you are already graphing, and I think that's wonderful. Time for a new page. Okay, so I have my graph. What is the first piece of information I need to put down or find on my graph? Not the vertex. Axis of symmetry. So that's going to be the red. Here, my axis of symmetry is x equals -4. So I go to 0, 0. On my x-axis, I move left 4, and I put a dotted line that goes through -4 on my x-axis. That is my axis of symmetry. The next thing I need to put down is my vertex because it exists on my axis of symmetry. My vertex is at -4, -1. So I go left 4, I go down 1, and I put my point. Questions on that so far? What should be the next piece that I go ahead and put on here? Say it loud and proud.
Focus.
The focus. So the -4, -9/8 should be the next thing that I put down. We use an X to indicate my focus. That way you do not mistake it for the vertex. This particular focus is going to be extremely close to our vertex, so it will look like it overlaps, but there is some distance between them. It's just very small. So I go to -4. I should pick a color first. I go to -4, -9/8, which is just slightly over -1, and I put my X because that indicates my focus. What is the next piece that I need to identify? The directrix. That's kind of the last piece that I have here, except for direction of opening. So this is going to be a horizontal line that goes through y equals negative 7/8. Again, this line is going to be extremely close to your vertex, and depending on how you drew your graph, it might even touch it. That is okay. We know in actuality there is some distance between them. So I go slightly above -1, and I draw a dotted line as best as I can. I have placed my axis of symmetry, my vertex, my focus, and my directrix. So what is the last thing that I need to do to finish this graph?
Parabola.
Draw the parabola. Which direction is my parabola opening?
Down.
Down. It should never cross your directrix. Never. So if you draw a parabola from here that opens up, you did something wrong. It should never, ever cross your directrix. So what I'm going to do is I'm just going to approximate what it looks like, and then I'm finished. So that is the graph of my parabola.
You just take for
They do take a little bit, yes.
no.
Would you guys like to do another one like this?
No.
We've done two now. We've done one that opens to the side, and we've done one that opens up and down. Are you okay with this? I know it takes a while, so I did want to leave it up to you. If you're okay with it, we are going to do a couple more examples that are a little bit different, and then I'll let you do some homework time. Okay, I don't hear anybody complaining or refusing, saying we need to do more. So let's move on to another type of example. These are much shorter. So in this particular example, I would like to write an equation for a parabola that has the following information or characteristics. It has a vertex at -2, 3, and a directrix of y equals 1. Okay, so whenever we're presented with a problem like this, the first thing I need to do is figure out which equation I'm going to be using. Am I using the y equals equation, or am I using the x equals equation? How in the world would I determine that from this information?
Maybe the directrix
Maybe the directrix,
because of the y.
because of the y. So which of those two equations down at the bottom of my table has a y equals directrix? Is it the y equals equation or the x equals equation?
Y.
It is the y equals equation. So I know that I am using the equation y equals a times x minus h squared plus k. That is the equation that I need to be filling information into. Do I have any of that information ready to go and be plugged in?
Yeah.
Yes. I have h and k. Hold on.
Huh.
Y is not something that we replace, neither is x. We just replace the h, the k, and the a. So I have my h is -2 and my k is 3. So I plug that in, I get y equals a times x minus a -2 becomes +2, and then +3. What is the last piece that I'm missing here? My a. So this one is actually a little bit harder to find just because we're not used to using a different type of equation. But I do need to look at what I've been given and how that is set up for a vertical opening parabola. I do have my directrix, correct? So what I need to do is I need to think about what that original equation for my directrix was, and then work backwards to find what my a value was. So what is the equation for a directrix for a vertical parabola?
Y equals k minus 1.
Perfect. K minus 1/4a. I know that my y value here is 1 because that's what my directrix was equal to. I know that the k here is 3. And I know it was 3 minus 1 over 4a. So from here, I need to work backwards to identify what my a value is and solve for a. What is the first thing I should probably move here to get a by itself? The 3. How am I going to move it? Subtract it over. When I subtract it over, I get negative 2 equals negative 1 over 4a. Multiply by 1 or negative 1? Negative 1. Why would I multiply by negative 1, Brandon? Because then I get rid of the negative and the 1. Or, well, I get rid of the negative. So I get 2 equals 1 over 4a. Now I'm kind of stuck. What could I possibly do? 4 or 4a? If I multiply the 4, that's awesome. But then my a is still stuck where? In the bottom. And that's really, really hard to undo. So what if I multiply 4a to the left-hand side? Then my a is on the same level as the rest of my problem, which makes it a lot easier to solve. So we're essentially just cross-multiplying here, except I'm really just multiplying this denominator because it's the only one that I see. So when I multiply it over, I actually get 8a equals 1. My goal is to get a by itself, so what do I still need to do? By. Awesome. So what does a equal, Alex, since you're on a roll?
A equals 1 over a.
And that is the last piece that I need to fill in here. That is my equation. We don't need to solve it. That is the equation. I didn't ask us to solve it. So that is the end of this problem. How did we like that one?
I think it was very nice.
Very nice. Compared to the last ones, it was a lot shorter. We are going to do at least one more of these. You guys ready?
No.
Yeah. About that. Okay. Let's go ahead and do this next one.
Is this our last week before we?
I think this will be the last one. The first thing I'd like to do on a problem like this one, where I was given a vertex of 1, 3 and a focus of 1, 5, is I would like to compare the vertex and the focus to figure out which coordinate is the coordinate that we changed. Because determining that will help me determine which type of equation I need to be writing. So which of the coordinates, the x or the y, is the one that changed from the center, or sorry, the vertex to the focus? The y. So which of my two equations in my table shows my k changing here to find the focus? The vertical, which is the y equals. Because in that table, for focus of a vertical parabola, it says my focus is h, comma, k plus 1 over 4a, which means that I changed my k while my h remained the same. So that's how we identified that this is the equation I need to be using for this parabola. Okay, so always look at what you've been given and use that to determine the initial type of equation. Do I have any of this information to start with? I have h and k, so I'm going to go ahead and fill those in. I acknowledge that my h is my 1 and my k is 3. Filling that in, I get x minus 1 squared plus 3 with the a still unsolved. How in the world am I going to solve for my a value here? Is this a directrix, Alex?
Sorry, I think I'm done.
You're okay. So I need to use the fact that my focus, or the y coordinate of my focus, equals k plus 1 over 4a. I know that the y coordinate of my focus is 5, and I know that the k value from my vertex is 3. So this is actually equal to 5 equals 3 plus 1 over 4a. That came out not even English. And now I'm going to do the same thing. I'm going to work backwards in order to determine what my a value was. What am I going to do first to isolate the a? Subtract the 3. When I do, I get 2 equals 1 over 4a. This is going to be funny. What next? I know. That's kind of fun. Yes, bold. Hold on. No. I put the 5 there because that's what the y coordinate of my focus was equal to. So I took that k plus 1 over 4a and set it equal to what the actual coordinate was in the focus that they gave me. Good question. So finishing this out, how am I going to bring that 4a up from the denominator to the top? Multiply it straight across. Well, not straight across, but diagonally across the equal sign. So when I do, I get 8a equals 1, which means a equals what?
6.
Brandon, I've missed you. I get a equals 1/8, which is just funny because that's what we had on the other one as well. And then the last thing I need to do is go ahead and fill in that a value. And then we are finished. Not nap time, but it is homework time.
What a coincidence.
So if you guys have any questions for me, obviously let me know. Those of you who are online, ladies and gentlemen, those of you who are online, please hang out for a second. That way I can make sure I counted all of you as present. And then if you want to, you can go ahead and get off when I tell you to. Yes, ma'am. I don't think that I missed anybody. Yeah. Oh, wait, Rowan shut up. I think Reese was one that I was missing. Poor guy.
Are we doing anything else the rest of the year that's not wrapping?
Undecided. Maybe a little, but not a lot.
I like wrapping.
You like wrapping? Can you wait till Sam gets back? Just go, Alex. My goodness. I'm so glad I'm still recording that. Really should have stopped that one.